We're in the home stretch, essentially. This is our last section of new content for the course, so I don't know if that makes you excited, but it kind of does me. Anyway, so this last notion of financial calculation that I want to talk about deals with loans and amortization. You can see the name back there, so there's a blank in the notes file. You'll also see the formula from the notes file sitting right here. We didn't make you fill it in this time around, so you're welcome. Um, we'll talk a bit about what the formula ends up meaning momentarily. I just wanted to give you sort of a brief overview of how this whole amortized loan thing works. So it comes up a lot in the context of things like mortgages. I believe most student loans also end up working on some kind of structure involving amortization. So basically, you make regular payments of some sort, mortgage payments, loan payments. You get the idea. And over each payment period, interest builds up. Your payment generally goes first to nuke the interest that's accrued, and then pays off whatever remains in the payment value to reduce the balance. So, as I said, mortgages are kind of the standard example for this, but I mean it works for just about any kind of like big loan payment plan. Fun fact: amortization literally means to make something dead. So when you say you're killing off your mortgage, you really are. Anyway, so as far as the formula goes, so you see here, R is kind of like we've seen, previously in talking about annuities. That's representing how much you're actually paying per month, quarter, whatever. A sub n is standing in for the amount that you borrowed, so you can think of that as a present value. Like we've seen since the chapter basically started, I is our periodic interest rate, N is the total number of payments that we end up making over the life of the loan. So, standard stuff. This formula may look a little bit familiar. We've really just kind of taken that present value formula for an ordinary annuity from the last chapter and gotten R by itself. Technically, we didn't really need to give you this formula. We've actually already done this process without mentioning it in a couple of problems in section 6.4. But no harm in having it there. All right, so let's get started. So we've got an example here. We've got a family. They've taken out a mortgage on a house. The mortgage value is $170,000. They're making monthly payments over the course of 15 years, and their annual interest rate is 6%. But then it's getting compounded monthly, so we need to do an N thing like we usually do. So in this instance, we've got 170 grand as our A sub n. Usual song and dance at this stage. It should feel really familiar at this stage. We take our annual interest rate of 6%, divide by 12. So our periodic rate is 0.005. And then N is going to be 12 times 15, because there's 12 months in a year. And that should give me 180 payments in total that are going to get made. All right, so now we can work out what their regular payments are by filling in the blanks in our formula. So we have 170 grand of 0.005. And down below, again, really important, make sure you enclose this stuff in parentheses. 1 minus 1.005 to the negative 180. Again, that negative is particularly important here. Make sure you keep it around. You pound through all the arithmetic. Again, it's you can type it all into one line in your calculator if you're careful with parentheses. And I end up getting to the nearest cent $1,434.56. So that's that's how much they're paying per month on this mortgage. All right. So we also ask you at that point, work out the total amount of their payments, and then, figure out exactly how much interest they end up paying over the life of the loan. So bear with me for a minute while I clear this off. I'm getting worried that these jump cuts are becoming more and more of a habit. I'm sorry. Anyway, so we want to work out the total amount of the payments that this family ends up, having to make over the course of their mortgage's lifespan. So we know how many payments they're needing to make. 180. We know how much each one of them is. 1434.56. When I worked this out, I got 258,000, 220, and then 80 cents. So there's their total amount paid on this mortgage: $258, $220, and 80 cents. All right. Last thing we ask: how much interest did they end up paying? Well, you can figure this out simply by subtracting the amount they initially borrowed from this total. So their total amount of interest: 258, 220, 80, minus that 170 grand that they initially borrowed, and that gives me $88,220.80. So, yeah, it's kind of an ouchy thing when you stop and look at it, but over the course of the loan, they ended up, paying over half the value of the loan in interest. So, welcome to mortgages. So that's one example. I want to take a look at another one in just a sec. Bear with me, another jump cut is coming. Well, when I actually hit the pause button. I guess the clean board is nice. Anyway, the next example talks about somebody named Rhonda. I've never been sure if this is some kind of Beach Boys reference, but I always end up having Help Me Rhonda stuck in my head as soon as I start talking about this example. So she's buying a $40,000 car. She knows her interest rate, and she knows how much she's wanting to pay per month. So we've got that taken care of. The catch is she's trying to figure out, essentially, she wants to know how much she needs to save up as far as down payment goes, which means, essentially, we need to work out exactly how big of a loan she can take out on this car. So this is a bit of a twist for us. So our R value is 800. We're given a 9% interest rate, again, monthly payments. So 0.09 divided by 12. So that should be 0.0075. Yes, it is. And she's wanting to make these monthly payments over the course of 48 months. I guess on the upside, we don't have to do any fancy footwork for once to work out in. We just know. So yeah, please don't multiply by 12 because you think it's a 48-year car loan. Please don't. Anyway, so that gives us everything but a sub n. So, whoops. Let me fill in the blanks in the formula directly. I almost slipped into like 6.4 mode. Anyway, so we have 800, our payment equals a sub n. We've got I up top, down below, 1 minus 1 plus I, to the negative 48. Again, note the parentheses. I'm sorry, I know I'm a broken record there, but that's missing parentheses is like number 1 on the list of mistakes students make on this stuff. So there's a reason I'm harping on it. I've seen it happen way too many times. All right. So like we've seen previously, everything inside these brackets is just a number. Like I said, it's a gross number, and I'm going to work it out for once. So as it turns out, when I worked this out, accurate to 6 decimal places, I got 0.024885. I'm not rounding. That's just how I'm going to write it on the board. So now I know what all this stuff is. To get a sub n by itself, I just need to divide both sides by that thing. So I'll put my squiggly equals, because, yeah, this is an approximation. And I got 0.024885. When I worked out this stuff again, when I had it in my calculator, I didn't round it off, but, yeah, be on the safe side there. Better safe than sorry. So when I worked that out, I got a total finance value of $32,147.83. That's how big a loan she can end up taking out for this car. Yeah, the car note, she was planning on spending 40 grand for it, which means she needs a really beefy down payment in my view. So, because in order to get the down payment, I subtract this guy from 40,000. So the down payment is 40,000 minus that guy, 32,147.83. So yeah, that is $7,852.17. Obviously, the 17 cents is just the deal breaker there. So that's an example sort of from each end of the spectrum in some sense, figuring out how much your payments are going to be. Also, if you know how much you can pay, how much are you going to be able to afford to borrow? The next example in the notes file runs kind of similar to this. A family is trying to figure out exactly how much house they can afford given a down payment amount and how big they can manage to make monthly mortgage payments on. So I want you to try that one for the assignment. I want to take a slightly different twist on this when we come back in our next video.